Okay, so I'm just going to repeat over what I wrote. Something went wrong with the video last time, so I'm just going to explain what I did in this problem. That's problem 1 for the Physics 2048 Fall 2014 exam. So the problem is asking, a train traveling along the x-axis is initially at the point xi at t equals 0. The train then travels 10 kilometers to the east, as shown in the figure. It then reverses direction and travels a distance t to the west, to the final point xf. If the train's average speed for this trip was 15 kilometers per hour, and its average velocity for the trip was negative 10 kilometers per hour, what was the distance d in kilometers? Okay, so let's look at the diagram right here that I drew. So we know that the train starts here at point xi, and then it moves to the right. So let's just write that as to the right, just one arrow right here. Let's see. Okay, and it moves to the right 10 kilometers, and then it moves to the left by an unknown amount of kilometers. Or okay, so yeah, so here we have that it's going to end up at xf, which could be here, could be here. We don't really know where it is. We just know that it moves in the opposite direction. So now we have our diagram. Let's look at what our definitions. We know that speed is just the magnitude of the total displacement. So it's adding the magnitude of the total of the displacement, of each displacement, divided by time, by the total time passed. And we also know that velocity is just adding each displacement. We're also taking into account the direction in which the train is going. So that means, since d is going to the left, that's the opposite direction. So d is going to be negative here. Here we're just doing the absolute value of each one. So we could even say negative d right here. It's just the magnitude of negative d, which is d. So 10 kilometers minus d over delta t represents our velocity and our speed. And we're told what each of these quantities are. We're told the speed is equal to 15 kilometers per hour, and we're told that the velocity, well, the average speed and the average velocity is negative 10 kilometers per hour. So now that we have that, we can work a system of equations in order to figure out what delta t is. So here we have this, the first one, the equation for speed and the equation for velocity. And we're going to do elimination in order to find delta t. So when we do that, we're going to add up 10 kilometers here, so it's going to add up to 20. These go away, as you can see, and then 15 minus 10 is 5. So we have 20 equals 5 delta t. So all we do at this point is we just solve for delta t. So we get that 4 equals delta t. Now that we have that, we are going to use the found value of delta t in order to find d. So we're going to pick one of these equations. It doesn't really matter which one. They're both going to give you the same answer. I'm going to pick speed, and then I'm going to plug in delta t into speed. And here we have 10 kilometers plus d over 4, which is what we found was delta t was, which is equal to 15 kilometers per hour. So what we do at this point, we multiply both sides by 4, and we get 10 kilometers plus z equals 60. 15 times 4 is 60. After that, 60 minus 10. We just move 10 to the other side, and we find what d is. D is equal to 50 kilometers per hour. I don't know if you can see it right here, right here. So that's how you do it.